I'm going to address 3 word problems that deal with finding the correct mixture. The first one, they're working with coffee. The next one, they're working with acid, trying to get the correct solution. And then the third one will be trying to create the correct alloy of copper. Okay, alloy is just it won't be pure copper. It's a mix of copper and other things. Okay. And I think it's good to watch all 3 because this first one is probably the easiest one to comprehend as we go along. All right. It's going to be very helpful to have a chart to organize what we're looking at. So we have 3 things to be concerned with here. We have $8 a pound coffee, we have $4 a pound coffee, and we have $6 a pound. So just to help us organize our thoughts here. Okay, so we have $8 a pound coffee, we also have $4 a pound coffee, and we want $6 a pound. Coffee. Okay. So these are basically the 3 categories that we have. And we're not really going to work with these figures in particular. We just need something to help us organize our thinking on this, okay? So we're going to have a chart. These are the categories. And then see what they tell us about these. So let me see. We're going to add $4 a pound. We have 20 pounds of coffee worth 4 a pound. Some number of pounds of $8 coffee is going to be added. So pounds seem rather important, so let's put pounds coffee here. And the $4 a pound, we have 20. Okay. $8 a pound, we don't know how much. It says how many pounds of $8 a pound coffee. So we'll just use a variable, x. And for this $6 a pound, we don't know how much we have. It's going to be more than 20 though, isn't it? Because we're going to start with 20 and we're going to add whatever x is. So we can describe the number of pounds of $6 a pound as x plus 20. Okay. We certainly need another category here. And it might seem redundant to repeat this, but we need to keep up with the value of this, okay? So let's say cost per pound. Cost per pound. Okay, that's a way of writing it. Cost per pound. And this is $8. This is $4. And this is $6. And we need to know the final worth. They give us a little clue there, the worth. How do we get a mixture worth $6 a pound? We need to keep up with the worth of each, let's say, sack of coffee. All right, so I'm going to put worth or value. And the importance of this might become a little more clear in a second. Let's first look at our $4 a pound coffee, okay, because we don't have any variables here. if we have 20 pounds and it costs $4 a pound, that means we've got a big old sack of coffee that's worth $80, right? We would multiply 20 times 4 to find out the value of that sack of coffee. So we're going to follow that pattern. That means I'm going to multiply $8 times some number of pounds, so that's 8x. And then this one, it's going to be $6 times however much coffee I have here. Okay, I don't know how many pounds that is yet. So this will be alright, the whole purpose of this chart is to try to organize your thinking on this. Alright, now I'm going to slide this up, give myself a little more room to work. What we want you to do is we're trying to set up an algebraic equation, and if we combine this much $8 a pound coffee and this much $4 a pound coffee, we're going to get this much $6 a pound coffee. So if we add these two, we're going to equal this. That can be a little bit tricky to see, but basically these two are going to get added and it's going to be equal to that. So this actually gives us our algebraic equation. I don't need this other stuff. That was just to help me organize my thinking on this. Alright, so let's write our equation and solve for x. We have, where am I going to work? I think I'll just work right here. 8x plus 80 is equal to 6 times x plus 20. You have to distribute this 6. I guess we'll slide this up, and I think my preference would be get rid of the 6x since it's smaller than 8x. This leaves us with 2x. And that's 120. Next we can get rid of this 80. So we have 2x, and that's all we have left here is a 40. Well, that's not much. Alright, now we'll get rid of our 2. And we've just figured out that 2 goes into 2 once. So we have just figured out that x is equal to 20. So I'm going to zoom out and take another look at our question, make sure we don't have to do anything else. Alright, x is 20. We're going to hang on to that information and look back at this. How many pounds of coffee worth $8 a pound? 20 pounds. Okay, taking a look at our next question. And we'll basically try following pretty similar approach. We have a 20% acid solution oh, we have pure acid 20%, and we're trying to get 50%. All right, so let's organize our categories here. We have 20% acid. We have pure acid, so I'll call that 100% acid. And then we want a 50% acid solution. So we want 50% acid. All right, and all we've done is just kind of try to organize our categories here. So we can keep straight what we're talking about. So these are just the categories. And let's see. And gallons, we're going to be working with how many gallons, okay? So let's put, for here, of the 20% acid solution, we have 5 gallons of that. Okay. The pure acid, or 100% acid, how many gallons? Okay, so we'll just put an X there. And however much 50% acid solution we end up with, it will be more than 5 gallons, because we're going to start with 5 and we're going to add pure acid to it. So we'll say X plus 5, okay? And again, we're going to want to keep track of these different categories. So let's say percent solution. Alright, so we have 5 gallons of 20%. 20% I'm going to write as just 0.2 or 2/10. 20% can be written as I'll write it up here, 0.20, but I can drop that trailing 0. Okay, so I'm just going to keep up with that. And then this is 100% acid. So this is actually 100% pure acid. Let's see, I'll write this up here. That's 100%. I can actually write that as 1.00, or just drop all that and just write it as a 1. And this, what are we supposed to end up with? 50%. And I'm just going to write that as 0.5 or 5/10. Alright. And then finally, we're going to describe how much pure acid is left, or how much pure acid is contained in each one. And this is a little bit strange. Well, they're asking how much pure acid gets put in, so that's kind of convenient. Alright, so we'll put gallons of pure. And this might seem a little strange, but if you multiply the number of gallons times the percentage of solution, it gives you the amount of pure that is in that solution. Okay, so 5 times 2/10 is 1 gallon of pure acid is in here. They took basically they had 4 gallons and they added a gallon of pure, and they got 5 gallons of 20%. Here I'm going to multiply again. 1 times X, well, that's X. And here it's going to look a little strange, but I'm multiplying still. So this is 5/10 times, okay? And just as in the previous problem, the purpose of this chart is to organize our thinking. If we add this to this, it's equivalent to that, okay? So that plus that is going to be equivalent to that. So this will give us our algebraic equation. Slide this up and write the algebraic equation. 1 plus x is equal to 5/10 times, and now we're going to solve for x. I'm tempted to get rid of the decimal here. I'll put up with it. Doesn't look that bad to deal with. So we'll distribute that 5/10 to each term. And when I multiply that, I would get 2.5, 2 and 5/10. And if I get rid of half an x, I'll end up with a positive half of an x. So I'm going to subtract 5/10 x. 5/10 the same as 1/2. And I think you understand, if I have 1x and I subtract half of that, I'll end up with 0.5x. All right. Let's bring down our 1. Don't forget this is positive. Slide up a little more. That's a 0, and we have positive 2.5. Let's get rid of our 1. That's really 1.0. And now one more thing, we have to get rid of this 5/10. So we'll divide by that. And of course this cleans up quickly. You have 1x or x. And then here, just to be safe, I don't want to make any mistakes, I've got 1.5, 1 and 5/10 divided by 5/10. You have to move the decimal, tell the world. Goes in there 3 times. So x is equal to 3. All right, now we're going to back out and see what the heck were they asking us for? Remember, x is equal to 3, okay? Let's go back up to the top. Or instead of remembering that x is equal to 3, I'm going to write x equals 3, and then how many gallons? We need to mix 3 gallons of pure acid. So to answer that question, we would say 3 gallons. And that would give us a 50% acid solution. If we have 5 gallons of 20%, we add 3 gallons of pure, we'll have 8 gallons, but we don't really care about that. They just said how much of pure do we have to add. We've got to add 3 gallons of pure. An alloy is just, instead of a pure metal, it's a metal made up of a combination of things. Back out 1. And we'll take the same approach with our organizing chart, okay? We need our categories here. I'm going to zoom out a tiny bit. So we have 10% copper, we have 80% copper, and we want 20% copper. All right, and again, these are just categories. We're not really going to do any calculations with this stuff here. We're just trying to organize our thinking. So these are the categories. We're talking about ounces in this case, okay? So that has to do with, well, I'll just call it ounces. And what do we have for the 10% copper? Well, let me make the chart a little easier to read. All right, 10% copper. How much 10% copper? How many ounces? We don't know. So we'll just use an X. Should be mixed with 100 ounces of an alloy that is 80%. So we're going to have 100 ounces here in order to get an alloy that is 20%. So we're going to start with 100 ounces and we're going to add some unknown number of ounces to get our 20% copper. So that's going to be X plus 100. And let's see, we want to keep track of the percentages of our alloys, so I'll just say percent alloy. So this is our 10%, and 10% can be written as 1/10. I'm just dropping the trailing zero. 80% can be written as 8/10, dropping the trailing zero. And 20% can be written as 2/10, dropping the trailing zero. Okay, and this part might seem a bit peculiar, but if I multiply the percentage of alloy times the number of ounces, it tells me how much pure whatever copper I end up with. If I was working with acid, it would tell me how much pure acid does this give us, or do we have really. Okay, so I'll say amount of pure. So we have 1/10 times 10. I'm sorry, 1/10 times X. I don't know the value of that yet. 1/10 times X. Then I have 8/10 times 100. That gives us 80. It's actually 80 ounces of pure, but I'm not going to worry about the units here, okay? So I have 80 ounces of pure copper here. And this one I'm going to get the same way. I multiply 2/10 times that amount. Okay? And again, this chart is just to help organize my thinking. If I add this to this, it's going to be equivalent to that. All right? So the sum of these two is equivalent to this. So now we have what we need for our algebraic equation. I'll go ahead and write the equation and solve for x. Slide this up. And I think in this one I might get rid of these decimals. I can clear an equation of decimals just as I can clear one of fractions. If I can move this decimal just one place and move this decimal one place, I won't have to look at them anymore. So I want to multiply each side of the equation by 10. Everything in here is going to be left alone for now. This stuff inside parentheses is protected, and all I have to deal with is what's in front. The way I change this will eventually work its way in there, so that's why this is still a balanced approach. So I'm going to multiply by 10, 10, and 10, and that will give us 1/10 times 10 is just 1x, or x. I could put 1 in front, but we don't have to. 10 times 80. Okay, that got a little bit large. This turns into 10 times 2/10 is just a 2. And then x plus 100 just drops down. Alright? At least now we don't have to deal with the decimals. To get to the x in there, though, we're going to have to distribute our 2. And I'd rather get rid of this x. If I get rid of that one, I'll have to deal with a negative. So subtract x. That's just 1x, or x. Okay. We need to get rid of that 200. Maybe I'll zoom out a little bit. And finally, so we have x equals 600. I think I'll write that way up here. And take a look at what they asked us again. Alright, how much of an alloy that is 10% copper should be mixed with this 100 ounces? We're going to have to mix 600 ounces of 10% copper to bring our 80% copper down to 20% copper. Okay, so the answer is 600 ounces.